ஸ்டார்ட் பண்றேன். Hi, good evening all. I'm your host for this session. This is Dr. Geeta Lakshmi, Strategic Partnership Manager from IFERP. I welcome you all for the webinar on Predict T20 Cricket Math Scores using Python, which is organized by Institute for Engineering Research and Publication in association with the United Innovators. Before starting our webinar, let's see a few glimpses of IFERP. IFERP is an Institute for Engineering Research and Publication, is a non-profitable professional association meant for research and development in the field of engineering, science and technology, and management studies. IFERP is on its way to digitize innovation process through our professional networking services, and thus by providing an integrated virtual scientific community, mutual engagement, exploring potential of researchers, creating a cooperative and collaborative academic environment. Not only that, as a leading organization for scientific research and assistance, IFERP promotes knowledge sharing in engineering and science and technology and management studies through its scientific conferences and events, and also by establishing student chapters, professional development programs, career and skill development programs, faculty development programs, webinars, workshops, journals, magazines, and proceedings. IFERP have stepped into a strong network in many developed and developing countries like India, Iraq, Maldives, Malaysia, Thailand, Singapore, Philippines, Indonesia, Taiwan, Vietnam, and UAE. IFERP existence across the world. We have more than 82,253 members in more than 100 countries. IFERP accomplishments. So for IFERP scientific events and collaborations, here we can see that we have organized 407 international conferences so far, and we have organized virtual events like FTP and webinars around 212, and 322 collaborations and MOA have signed. We have in-house journals, 36 plus in-house journals we have. We have established 12 student chapters. And coming to IFERP publications, totally we have published 48,593 articles. Among that, 26,783 Scopus publication, 12,421 for Web of Science publications, 1,000 plus SCIE publications, and delegates attendance 36,745, and scientific presentations around 28,673. What we do for students? Through IFERP, we will help the students to participate in hackathons. We are providing them a seed funding program. We will help them to participate in the internship program and coding and project competition. They can participate in guest lectures and online courses. They can attend the workshops and webinars and placement training. What we do for faculties? Coming to the faculties, IFERP will help you to participate in the scientific events. They can also get the seed funding program, and they'll get the career support and soft skill development. We will support them for publication assistance, and they can participate in FGP workshops and online courses. Based on their profile, they can be a keynote speaker or editor and reviewer for the technology journals, and they will get that session opportunity based on their profile. Coming to the publication, we are supporting them for book chapters also. Apart from that, we are helping them to do patent filing assistance. What we do for institutions? For institutions, we will support them for grants and awards, MOU with industries, FDPs, workshops, webinars and online courses, publication assistance and patent filing assistance, career and soft skill development for faculties and students, for establishing student chapter, and scientific conferences and events. IFERP conference sponsor schemes. In this, we have three categories. One, academic partner, which IFERP is organizing an international conferences across the globe. In that, they can be an academic partner For that, institution need to give minimum 10 registrations for the conference, and the organizer will be the IFERP and the academic partner will be the institution, like a co-organizer. They will be getting the benefits like promotional opportunities, academic opportunities, and professional opportunities. The second category is IFERP organizing sponsor. Here, you need to give minimum 50 registration from your institution, and venue will be your institution, and no monetary involvement between institution and IFERP. Scientific conference management system, organizational management, global promotion and networking, design of collaterals, and the registration fees will be collected by IFER. The third category is the institution organizing sponsor. The registration fees will be collected by the institution, and the institution will pay to IFERP for the services rendered by IFERP. Designs of collateral, website development, abstract and registration management, global committee management, program coordination, speaker management, and digital marketing and email marketing. All these services will be provided by IFERP so that the institution can pay to IFERP. This will come in this institution organizing sponsor category. Coming to journals and publications, IFERP is a leading publisher of scientific articles in Scopus, ESCI, Web of Science, SCIE, UGC-CAM, and Google Scholar Index journals. IFERP is a publisher of scientific, technical, and engineering journals. IFERP has more than 30 plus in-house journals. More than 48,593 research articles are published by IFERP. Here we have given the website link for the journals and publications, and the Techno-Orange journals also we have given the link here. Coming to the IFERP membership categories, we have student membership, professional membership for faculty members, and institutional member for institutional membership. Coming to the IFERP chapters, we are student chapter and the special interest community chapter. Coming to for establishing IFERP student chapter in your institution, we need minimum 50 student premium members and 3 premium professional members from your institution for establishing student chapter. Student chapter benefits, as I said earlier, events and awards like we will act as a link between the institution and the industries, and seed funding programs, workshops, webinars, guest lectures, hackathons, coding competition, project competition, and Olympiad. They will get all these benefits through this. And career support like placement training, online courses, internship support, career news, resume building, entrepreneurship development, industrial visit, startup street, and leadership training. For publication assistance also we are providing for the student chapter. And book chapters and online courses, we have book chapters under process. One is application of artificial intelligence and machine learning in healthcare. And the second one is machine learning algorithms for intelligent data analytics. And third one is smart environmental science, technology, and management. We have online courses. This artificial intelligence and machine learning will be launched by this month. Very soon we are going to launch. We will be announcing the date. And we have IFERP Academy and industrial mentorship is under process. And these are all our IFERP upcoming conferences. One, we have an international conference on multidisciplinary research and practices, ICMRP, which is going to be held on 22nd and 23rd November by this month in Phuket, Thailand. And the website link we have given here. And for one more, we have in the next month, which that is International Conference on Recent Challenges in Business and Management, ICRCBM 2022, which is going to be held on 16th and 17th December in Dubai. The conference link is mentioned here. And these are all our associates, partners, and collaborations. Now coming to the session, predict T20 cricket match scores using Python. Before inviting our speaker, the session, Mr. Aman Sharma, to take the spotlight, I would like to give an introduction about him and his expertise. Mr. Aman Sharma is a data and deep learning enthusiast and a Pythonist with a more than 2 years of professional experience, with affiliations from esteemed organizations like Major, um, Hacking League, Microsoft Learn Student Ambassador, and Google and Developer Students Club. And Mr. Aman has an experience in multiple computer science domains. His primary skill domain is computer vision and cognitive computing, and also experienced across other skill domains like native app development, backend web development, and DevOps. Sir, it's a privilege to have you as our keynote speaker for this session. Sir, now you can deliver your keynote, sir.
Sure. Good evening, everyone. So I hope my screen is, let me try to share my screen. Just give me a moment. I don't have the permission to share my screen. Can you provide me the permission?
Yes, sir. Share screen. Sir,
Yeah.
are you able to share your screen now, sir? Because we have changed your option to co-host now.
Just give me a moment. I'm sorry, I'm having some trouble with the Zoom. Just give me a moment.
Okay, sir.
I think it should be visible now.
Yes, sir.
Is the font size good enough, or should I increase it?
Yes, sir, this is visible, sir.
All right. So coming on to the main topic of this session, we are trying to predict T20 math scores and results using Python. So one thing that I'd like to clear beforehand, before I actually begin with the session, is there's actually no solid way to predict the math score because there are a variety of factors involved during a cricket match. So these variety of factors can be fall of wickets, or let's say the weather involved, or the type of pitch involved. So all these factors make it impossible to predict beforehand what the score of a certain team will be. However, one thing that we can predict is whether or not out of the two teams which one is going to win or which one is going to lose. So we can have a rough estimate regarding the probability of that thing, but regarding predicting scores, there are a lot of factors involved, so that makes it a bit tough task. It's not completely impossible, but for the scope of this presentation, I'll restrict it to predicting whether which of the two teams will win the match or not. So uh, the techniques that I'm going to discuss in this particular demonstration are going to be very generalized. Now, these techniques can further be translated into more advanced models for predicting uh, the match predictions with a much higher accuracy. So coming on to the first step of working on a project, the first step will be importing all the Python dependencies that you might need within the project. So we have done that here. Uh, in this particular project, we are going to primarily work with NumPy, Pandas, as well as Matplotlib. So we'll try to develop a statistical model based on which we can predict which one of the two teams will win. So coming on to the next step, which is going to be loading the data set. So we have a data set over here. So let me show you the quick glance of the data set. So we have three files over here. The first one is batting underscore T20 CSV. Second one is bowling underscore T20 CSV. And the third one is fielding underscore T20 CV. CSV. Now the thing is, these data sets have information regarding player performances from a history, like from way back, all the way back to 1800s. So the game that we are going to play uh, in this particular demonstration is going to be a fantasy cricket league. So we can create our own fantasy T20 teams, and we'll predict whether or not the team will win or not. So this is how we are going to approach this problem. So first thing that we do is we load these data files into a pandas data frame object. So the steps for this is pretty simple. We get the path of the data files in this particular step. Then we finally provide this path to pandas.read CSV function. And once this is done, the CSV file is loaded into a data format into this batting underscore df variable. Similarly, we do the same thing for bowling underscore df and fielding underscore df. So now our data is loaded, and we can take a quick look at how the data set looks like. So quickly printing the first 5 rows of the batting data set, we get the following information. We have the player data for how long the player has been playing, how many matches the player has played, the number of innings, the number of not outs, the total runs the player has scored uh, within that game span, what is the highest score that they've achieved, then their average score, and a few other things like the strike rate, the number of centuries that they have achieved, the number of 50s, or let's say the number of boundaries they have hit. So this is quite an old data set, like I mentioned before. It ranges from all the way back to 1840s and all the way up to 2019. So currently there is no latest data set available for the T20 matches, for example, the current ICC World Cup that's going on. So we have to make do with an old data set for this demonstration. Now, we did the same for the bowling data frame, and we see there is a bunch of information over here as well. Then we do the same for the fielding data set and some information here as well. Now, if you take a look at these data sets, you'll find that there is a lot of unnecessary values in the data set. For example, the unnamed 15 column is just a bunch of garbage variables that we don't need. So we can remove this one. Then the unnamed zero column is also a garbage value, so we don't need this one as well. These are simply indexes that were saved on earlier, so we can drop these as well. Now we don't need span because again, this is going to be a fantasy cricket league, so we don't have to know which time period the player has been playing from. So we can drop these columns. So coming on to the next step within this process, we are going to pre-process the data. Now the data pre-processing will involve, first of all, removing some uh, unnecessary columns, then some kind of feature extraction where we try to extract a feature from the data set, and maybe we can use this feature later on in our modeling process or the exploratory data analysis process in order to understand what the data looks like, or in order to derive some trends or insights from the data. So in this step, we are going to pre-process the data. Now, the first thing that we are going to do here is we are going to remove the unnecessary columns from the data set. So like I mentioned before, there are some unnecessary columns in the batting data set. These columns are unnamed 0, span, and unnamed 15. So we are going to use the drop method of pandas data frame in order to remove these columns. So the syntax for this is pretty simple. We have the data frame object, then we use the dot drop method in order to remove these columns. We provide the columns in the form of a list, and the in place equals true parameter simply says that whatever the changes that we are making here are to be saved directly in the data frame. So if this particular thing would not have been here, we would have received a different data frame object, which would have not altered the original batting.df data frame object, but it would have simply created a new data frame object. Now here we are simply making a change to the original data frame object. Simply we remove the columns unnamed 0, span unnamed 14, and BBI from the bowling data frame. And from the fielding data frame, we drop unnamed 0, span, and unnamed 11 columns. So now, after removing these columns, let's quickly print what the bowling DF will look like. So it looks something like this now. All the unnecessary columns have been removed. Let me do one more thing. I'll start running these columns one by one so we can see the progress as it goes. So the first step, we imported all the necessary modules. Then we loaded all the data sets. And one by one, we print all the data sets. Now in the third step, we begin with the pre-processing. So first of all, we drop all the unnecessary columns from the data set. And now we can quickly print the bowling data set to see if the columns have been dropped or not. So as we can see, the columns have been dropped. Similarly, we can print maybe the batting data set as well and check whether the columns were dropped or not. So we'll print first 5 rows. Now by default, the head function prints the first 10 rows of the data frame, but we can specify the number of rows that we want. For example, if we do a 2, that is going to print the first 2 rows of the data set. So as we can see, the unnecessary columns were removed. Now we come to the next step, which is going to be a kind of a feature extraction, where what we are doing is we are separating the name of the player from the country. So country is again another feature that we can use later on in order to make some kind of predictions, or let's say gather some insights from the data. So for this, what we do is uh, I've written a separate function for this particular thing that separates the name of the player as well as the country. So the function works something like this. First of all, we take this data frame object, and then within the data frame object, we take the player column and we convert it into a numpy array. Now we take this, we make these two empty lists called player name and player country. Then this particular step, this particular part of the code, what it does is it is looping through every name within this player column, every item within this player column, and we are basically splitting it into the name of the player as well as the country. So after doing this, once the player name and the player country has been separated, we simply append these items to the player name and player country list. And finally, what we do is we create one more column within the data set called country, and we simply assign all the values in the player country array to this new column that we created, and we override the player column to now just keep the names of the players rather than the player name plus country. So this function is going to simply, once again, I'll repeat, this particular function separate name from name country from data. This is going to separate the name of the player as well as the country of the player from the data. So once we have defined the function, we run this particular function for all the data sets that we have available. I'll quickly run this. Once this has finished execution, so after that, let's quickly see what was the result of this one. So we will print the batting data set here. And as you can see, the name of the player as well as the country, these two things have been separated. So that's what we wanted to achieve. And this particular function has done it for us. So now we have created another feature out of this data set known as the country label. So this will help us maybe in the future. Let's say we want to organize a fantasy cricket where we don't take players from any team that we want. We take players only from particular countries. For example, let's say we want to have a India versus Pakistan match, so we can take players only from India and only from Pakistan. In that case, in that particular scenario, it might help us determine like which team will win. or let's say we want to generate some trend from this data. In that case also, it will help us. So I'll show how we use this column for generating from some insights from the data. So once we are done with this, now the next thing is there are a lot of values over here. These appear as numeric values, but actually these aren't numeric values. So let me quickly print something for you. Um, so we have batting data, and within the batting data set, we have a column. Let's take runs. So runs is, it appears that it is numeric data type, but actually it isn't. The data type, as you can see, is object. Object is kind of a generalized data type within NumPy and pandas. So we first of all need to convert this into a numeric data type so we can start playing around. We can start modeling something around the numeric data type that we are more focused on as of now. So the next step in this data preprocessing process will be to convert these object or string data types into numeric data types. So we have again defined a function for this one. So the function convert to numeric simply takes a data frame
Sorry for
object.
the interruption, sir.
Yeah.
Sir, we have one question in the chat box. I think you can also view that question and answer. In that, they have asked, can you share us the data set so that we can try parallelly?
Yeah. So let me quickly do one thing. I have created a GitHub repository for the same, and what you can do is you can maybe clone the GitHub repository and play along with me. So let me quickly share that one.
Thank you, sir.
The screen is still visible, right? I'll share that the same thing in the chat as well. You can clone this repository, and within this repository, in the data folder, you'll have all the data sets. And in the SRC folder, you'll have the Jupyter notebook, which will let you play around with this data set. Coming back to this thing. So yeah, it is going to take a pandas data frame object, and it is going to take the list of columns that we want to change the data type for. So it will iterate through all the columns, and for each column, it will perform this pandas to numeric function that takes a column, which is basically a pandas series object or maybe a numpy object, and on that series or numpy array object, it performs the conversion where it converts from object or string data type to a numeric data type, which can be integer or float. So we perform this function on all the data frames. So we have batting data frame, bowling data frame, and fielding data frame. We have selected a few columns over here that we want to perform the conversion for. So this is how it is going to work. Once we run this, all the data sets have, all the columns have now been uh, converted into a numeric data type. So let's perform the same check once again. We take runs, we run it over here, and now if you see, the data type is float64. Earlier it was object data type, now it's float64, so the data conversion has been done. Now since we have numeric values, we can start maybe modeling a solution around it or performing some other activities with these numeric values. So it's no longer a string data type, but a numeric data type. Now, one more thing. Let's take a look at our data set once again. In this batting data set, you'll observe there are a lot of, first of all, NaN values. So NaN is simply not a number. And basically what NaN values are is that these are non-numeric values, or you can think of them as missing values. So when you're filling an Excel sheet, sometimes you leave out a few columns, a few boxes in there. So those boxes, those empty boxes are basically your NaN values, not a number values. Now, apart from this NaN, you'll observe that there's one more thing over here, a simple dash. So sometimes what happens is you can denote your empty values by a dash, or let's say by writing NA, or uh, yeah, you can have any value that you want in order to denote uh, these empty values. You can even have a dot for that same matter. So for this particular data set, the creator of this data set chose to use this hyphen value for denoting empty values. So what our next task will be is that we are going to remove all the columns, that all the rows that have NaN values. And apart from that, we are also going to remove all the rows that have these dash values, because since not enough data is present for these particular players, we can't model a solution around this. So we have to remove these players from our fantasy league. So this is what we're going to do next. I think it will be better visible, the hyphen thing, if we check the bowling data set, maybe. Let's take a look at that one. Okay, these have a lot of NN values. Let's take a look at fielding data sets. Oh, all right. So it was best visible in case of the batting data set. But yeah, I hope you got the point. Now, coming on to how we are going to remove the NN values. So I've defined another function for this one. Now, this function takes a data frame object as one of the arguments, and it is not returning anything. It is just going to replace all the NaN values. I mean, it is going to drop all the rows within the data set that has NaN values. So the first thing that we are going to do is we also have to remove these kind of NaN values, these kind of empty or null values. So the first thing that we're going to do is, in order to generate some kind of homogeneity within the data set, we'll first of all replace all these values, all these hyphen values, with NaN values. So np.nan is simply these NaN values that are being displayed in the data frame object above. So what we do is, the first step, we replace all these dashes with NaNs. Once this is done, we simply use the pandas data frame drop.na method. And since we are using inplace.true, so like we saw in place earlier as well, when we are using inplace is equal to true, in that case, whatever change that we are making on the data set, that gets permanently changed within the original data frame object instead of creating a new data frame object. So we simply do this in place.true drop na, and this is going to remove all the rows within the data set that have NaN values. So for example, this row indexed 2004 is going to be removed because it has NaN values. Then after this is done, we reset all the indexes, because there's going to be a lot of indexes within this data set in the middle that will have the rows removed. So we need to reset the indexing once again for the data set. And that's what we are going to do. We're going to run this function for all the data sets. And once that is done, let's take a look at batting data, all the data sets once again, for that matter. So we have batting data set. And as you can see, now there are no NaN values. And also the number of rows have been reduced because we deleted a few rows. So let's check the same for the fielding data set. Now we have a total of 2003 rows, and earlier we had a total of 2006 rows. So a few rows have been removed from the data set in order to make sure that all the NaN values are removed. So now we have a clean data set. So with this clean data set, what we can do is we can move on to the next step of our project. This next step of our project is going to be exploratory data analysis. So the question is, what is exploratory data analysis? Basically, we have a data set, and within that data set, some trends are hidden. Some, let's say, some information is hidden that's not directly visible to the naked eye. So the task of a data scientist, a data analyst, is going to be to extract those insights with the help of your code. So that's what we are going to do in case of exploratory data analysis. We are going to analyze the data in order to do some exploration within it. In order to gain some insights from the data. So the first thing that we are going to do is, let's see country by country distribution of the top 50, or let's say top 100 players in each category. So we have a data set here. Let's take the betting data set. We have this betting data set. Now there are a lot of players in this data set. Each of these players belong to a certain country. For example, Virat Kohli is from India. Rohit Sharma is from India. Then Guptill is from New Zealand. Shoaib Malik is from Pakistan. So these players, these top players belong to some country. Now what we are going to do here is we are trying to see out of the like the top 100 players we have in both the categories, batting and bowling, how many players belong to each country in this top 100 category. So this will give us a overview of how strong the team of a particular country is or has been in the past. So let's take a look at this one. The first thing that we need to do here is just let's come back to the data set once again. Now, according to this data set, Virat Kohli has played 70 innings but has total runs 2633. Now he has played less number of innings as compared to Rohit Sharma, but he has the same number of runs. So we need to do something in order to normalize the score. Virat Kohli has scored the same amount of runs in much less innings as compared to Rohit Sharma. So obviously he's a better player than Rohit Sharma. Now, in order to make this score, we need to normalize the score. So what we can do is let's say for betting, what features can matter? The number of innings the player has played, the number of runs a particular player has scored, uh, the player's average score per match can also matter. Then the strike rate during a particular match can matter. So all these factors tell us how good a player is. So in order to calculate the ranking of that player, we need to bring in these factors. We need to make sure these features get factored in while calculating a normalized score. So now we are going to normalize the scoring for this particular data set, and then we are going to rank these players based on how good they are. So for this, I made a mathematical equation basically, and what this mathematical equation does is it multiplies the total number of runs a player has scored by the product. It multiplies this particular part by how many total runs the player has scored divided by the number of innings the player has played. So this particular thing will factor in a lot of things. First of all, this will factor in how much the total score of a player has been throughout his career. Then this is also going to factor in how less or how more number of innings the player has played. So this particular function, what it does is uh, it'll be best visible in case of Virat Kohli and Rohit Sharma, where they have the same number of runs, but a different number of innings. So this will clearly differentiate Virat Kohli from Rohit Sharma. So once we have this score. So what's going to happen is, now let's say Virat Kohli's runs is 2633. If we multiply it by some other factor, which is obviously going to be greater than 1, because the number of runs is much higher than the number of innings Virat Kohli has played. So this becomes a huge number. Now this will be a huge number for all the players. So what we need to do is we need to do something in order to normalize the score to a smaller factor. So what we simply do is we take the maximum score that has been scored by a player. So the number is 2633, and we use that score to divide this particular normalized score that we calculated earlier for each and every player. So this simply, what it simply does is, let's quickly, I'll comment this part out and I'll show you what's going on within this particular code. So now we multiply 2633 by 2633 divided by 70. So the score comes out to be this huge number, which is something that we don't want. So we take this particular number and we divide all the values in this column by this number. So this will eventually normalize this entire score. So now upon that division, the normalized scores look somewhat like this. So Virat Kohli has a normalized score of 1 because he's the best player. Then after that, the second best player turns out is MJ Guptill, and his normalized score is 0.748. Then comes Rohit Sharma, whose score is 0.729. So by using this simple technique, we have normalized the scores and ranked all these players according to how well they have played throughout the career. So this particular comparison gives us a basic ranking in terms of like their T20 career, and a basic ranking in terms of how well they have played throughout the career. So now we have this data set, and the next thing that we are going to do is we're going to do perform something similar for the bowling data set. The bowling data set as well. Let's quickly take a look at that one. Yep. So in case of bowling data set, we have something similar going on. We have total number of overs, how many runs a player has given so far, and the total number of wickets they have taken, what is the average runs they give out during an over or a match, and then what is the economy, things like these, how many matches they have played, how many innings they have bowled for. So uh, we need to again create a ranking based system for these players so that they can be ranked according to these variety of factors that affect how good a bowler can be. So again, we take in some factors. So these factors can be the number of runs the player has given out. Then this can be divided by the total number of overs the bowler has bowled. So this also factors in the average during each match. Then we multiply it by the total number of wickets the particular bowler has taken. So this gives us a rough idea of how good uh, how good the bowler is. Now again, we normalize the scores. So the final result that we are going to get is something like this. So turns out, according to this ranking, throughout the career, up until 2019, Malinga was the best T20 bowler. Then came Shahid Afridi, TG Saudi, Shakib Al Hasan, so on and so forth. So we now have a ranking based system for both batsmen as well as bowlers. Now we can kind of extract some information out of this. So what we are going to do next is we are going to plot the distribution for top 100 players country wise. So this will give us a rough idea of how many top players have been there from each country within top 100. So doing it for top 100 batsmen first. So first of all, what we did is we took the sorted data set where we ranked the players according to their normalized scores. Then this particular line of code, it is simply calculating how many players are there from each country within this top 100 list. So I can quickly print this as well, which will give you a quick uh, idea of what we're doing here. So printing this, okay, top 100 batting is not defined. Yep, printing the data, we see that out of the top 100 players up until 2019, Pakistan had 11 players within the top 100 for this particular data set, not in 2019, all the way up until 2019. Then South Africa had 9 players, Australia had 8, West Indies 8, England 8, India 8, so on and so forth. So this gave us a rough idea of what the top 100 all-time batsman distribution looks like. So we plotted the same thing on a bar graph. Now, this bar graph, the advantage of graphs is that graphs gives us information at a glance. So instead of going through, let's say you want to present your work to someone else, in that case, they won't have to go through your code in order to understand what's going on. They just take a look at your plot and they'll understand what's going on here. So this will give them a idea of how many players have been there in top hundreds of all times from each country. We do a similar thing for uh, bowling as well. So in case of bowling, we again get this plot that tells us how many players have been from each country within the top 100 of all time. Now we have finished one more part of this, which is exploratory data analysis. Now this was just to give you a rough idea of how you can approach data analysis part. You can perform some more data analysis operations on this particular data set. You can maybe plot the top 5 players, or let's say um, which player has the highest strike rate. You can create a lot of charts with this data set. But the point of demonstrating these two particular graphs was how you can perform feature extraction and then use that extracted feature in order to generate plots or gain some insights from the data. Now we come to the final part of this event, which is we are going to generate a statistical model for determining which team will win. Now, for this particular step, we're going to assume a game of fantasy cricket match. So in case of fantasy cricket games, what you do is you create your own fantasy cricket team and then you battle against someone else's fantasy cricket team. So during that fantasy, like when you create those two fantasy cricket teams, you can, before the game actually begins, you can get an understanding of which team is going to win. So a particular model, a particular statistical model is going to perform the same thing. Now, this is just the version 1 of our result predictor. It will predict by what is the probability of winning for both the teams. Now, this is just going to be the version 1 of our result predictor. You can modify the code even more. I can give you some insights on how you can modify the code later on after this session in order to make a more robust model for the same thing. But this is going to be a very generalized model where for each of the features that we are considering within our model, we are providing equal weightage to every single feature. So like I mentioned before, you're going to have two teams and your model is going to predict what is the probability of winning for each team. For example, we'll go through this code a bit later on, but first of all, I'll explain what I'm talking about. So we are going to have two teams. As we can see, we have some batsmen, some bowlers within our team. Then similarly, we have team two where we have some batsmen and some bowlers. This is a fantasy cricket team, so you can have players from any country that you want. It doesn't matter. Now, this predict winner function is going to take team one, team two, and the batting data set, the bowling data set, and based on these values, it is going to predict what is the probability of win for each team. For example, for team one, the probability of winning comes out to be 63.89%, and for team two, it comes out to be 36.10%. So this gives us an understanding, a rough idea before the match that which team has a higher chance of winning the game. Obviously, you can't predict with certainty which team is going to win, or you can't predict with certainty what is going to be the final score after a match or after an inning. So this is what is a more feasible task, predicting the probability of winning for each of the teams. So now we know that this particular function is going to take team one, a dictionary, team two, another dictionary, and then two pandas data frame objects, and it is going to predict the probability of win for both the teams. Now let's go through the code now. So I have broken down this code into three parts. The first part is the main function called predict winner function itself. Then we have two utility functions called calculate batting score and then calculate bowling score. So what we're trying to do here is we take all the players within the team, and we are trying to calculate the combined feature score for all the players involved, and then based on the combined feature score we try to predict which team has what probability of winning. So in order to calculate the feature scores, we first of all initialize we're first of all going to do this for team one, calculating the combined feature score for team one. Then we do it for team two, and finally we calculate the probabilities. So coming to calculating combined feature score for team one, we initialize the total score, which will involve the bowling score as well as the batting score, as you can see here. So we initialize it to be 0. Now we separate out the batsmen and bowlers. So as you can see, we have a dictionary which has first of all batsman key involved, and for the batsman key we have a list of batsmen. Then same for bowlers, we have a list of bowlers. The same for team two. So we separate out the batsmen and the bowlers. Then we calculate the batting score. This batting score, calculate batting score function is going to take first of all the batting data set, and it is going to take the list of all the batsmen within a team. Similarly, calculate bowling score is going to take the bowling data set and is going to take the list of all the bowlers within the team. Now let's take a look at the calculate batting score and calculate bowling score function. So coming to the calculate batting score function, this function takes a data frame object and the list of batsmen that are going to play. We initialize the batsman like batting score as 0. Then we iterate through each and every batsman within this list. So I've just wrapped it around a try catch block, a try except block in order to check if something is failing or not. But I mean, some player is found or not within the list. So it's not required as such, but this helps you with the debugging. So I did that part. Now, what we are going to do is we are going to search for this player. Like we're going to iterate through each and every name within this batsman list, and we're going to search this particular batsman within the within the batting data set, and we're going to extract values for that particular batsman. So the process for this is simple. We create a pandas mask. Now this mask is basically what it's doing is it's going to take all the rows where we have this particular name for player. So we generate the mask and then finally we get the player here. So this particular part, it is going to take return an entire data frame object, but we only require the first row of that particular data frame object. So we do it like this. And now we have a row, an entire row that is associated with that particular player. So we again calculate, we have a kind of function here. I mean, a mathematical function here that calculates the score for that particular player. So this particular mathematical function involves the total runs the player has scored, then another factor which is total runs scored divided by the number of innings the player has played. We also factored in this time the strike rate of the player. So the strike rate of a player also tells us a lot about how aggressive the playing style is. So this can be important factor in determining whether the team will win or not, or what the probability of the win is. Because the more aggressive a player is, the more is the probability that they'll generate a higher score. And if they generate a higher score, it will be tougher for the opponent team to chase that score. So I factored in this particular feature as well. Finally, what we do is we add the player score to the total betting score for the team. And finally, we return the betting score. Now, something similar is going on inside the calculate bowling score function as well. So we iterate through all the bowlers. We calculate the player score. This player score now factors in the total runs that the player has given to the other team, the number of hours the player has bowled, then how many wickets the player has taken, as well as the economy of the bowler. So the more economical the player is, the better it is for the team because they give out less number of runs and they take more wickets. So that simply tells us how good the bowler can be. So it was important that we factor in the economy feature as well while calculating the player score. Now, we finally add the player score to the team's total player score and we return this score. And in the end, what we're doing is we're adding both the batting score as well as the bowling score to the team's total combined feature score. So this gives us the total combined feature score for team one. We do a similar thing for team two. Now we are simply calculating the percentage, which will basically give us the probability of the win. So once we have calculated the probability of the win, we are printing the probability for each of the teams. So this gives us this nice result over here, which tells us what is the percentage probability of both the teams winning this particular fantasy league. So this was an overview of how you can model a statistical model in order to predict uh, like what is the probability of win for each of the teams. Now, one more thing that you can do here is I have included just a few features while determining the player score. So the next thing that you can do in order to try out how things work out for you, I mean, after the session, I'll highly suggest you clone this repository and you give a hands-on to this notebook on your own. So that will give you a better understanding of what's going on inside the code. So yeah, while you're playing around with the code on your own, what I'll suggest is you can try to factor in some more features over here. So for example, I have taken only runs, the number of overs a player has bowled, the number of wickets they have taken, the economy. However, there are more features as well. So let's take a look at this one. We have number of maiden overs the player has bowled. Then what is the average runs they give out during each match. So we have things like these, information like these. So you can try to factor in that information here as well in order to calculate the bowling score of a player. Now something similar can be done for the batting scores as well. So you can try to factor in more features over there as well. Now one more thing. as of now, we have given equal weightage to all of these features. So if you take a general algebraic I mean a mathematical function, so it is y is equal to mx plus c, where m denotes basically the weight associated with the variable x. So I'll quickly write it down as well. Y equals mx plus c. So this is the weight associated or with this variable x. So x is going to vary, m and c are going to remain the same. Now, what you can do for now, what we have done is we have provided weight that is m equal to 1 for all these features involved. But you can try to maybe play around with these weights and see by giving weightage to which particular feature more, you get a more accurate results in terms of which team has a higher probability of winning. So you can play around with the weights for each of these features. And yeah, this is going to be the second, let's say, a task for you after this session is over. You can play around with the weights and the features in order to develop version 2 of our result predictor that can be more accurate than the version 1 that we have generated during this particular session. So yeah, this was task 1 for you. Now, after this, what you can do is maybe you can create data sets of your own. So one of the biggest problems currently, while modeling some kind of solution for this particular thing for predicting maths courses, uh, not a lot of data sets are available for the same thing right now. So you can try creating your own data sets and see, maybe try to develop a statistical model for the same. So this was a quick overview of how you can use Python in order to develop a model, a solution where you can predict the probability of winning for two teams involved in a T20 cricket match. So yeah, this was it on my end. I'll quickly show the repository as well and how you're going to use that one. So let me just reshare my screen quickly once again. If there are any questions, you can ask now. I'll answer those.
Sir, am I audible, sir?
Yeah, you're audible.
Yes, sir. Shall we go for question and answer session, sir?
Yeah, that will be perfect. So I've already shared the link for the GitHub repository. You can clone the GitHub repository and just create a virtual environment. Within the virtual environment, you can do a quick pip install requirements.txt, and that will set up your development environment, and then you can start playing around with the code and change it, modify it on your own, and see how things work out. In case you have a doubt regarding the same, you can maybe shoot your doubts on my LinkedIn, and I'll answer them later on
Okay, sir.
after the session as well.
Okay, sir. Anything else you want to continue, sir, or shall we go for question and answer?
Yeah, you can go for question answers.
Okay, sir. From the participant side, audience, is there any questions? Do you have any doubts? Ravichandran, sir, do you have any doubts, sir?
No, madam, no, madam.
No, sir. Yes. Yes, sir. Please tell me. You can say your question, sir. What else you have doubts?
Any questions
can,
from the audience?
Any questions? Okay. Yeah, one question. Is this can be done in automation, sir? From Korla Harshita.
Automation in terms of what? Like, what do you mean by automation here? Can you please elaborate so I can answer accordingly?
Korla Harshita, what kind of automation? Can you explain?
What I am inferring from your question is basically you're trying to automate this entire process. So like we have a data set over here. We have all the functions already defined. So what you can do in this case is you can maybe create an API solution for the same. So once you have the API created, all you need to do is you need to provide a list of the two teams. I mean the two dictionaries of the two teams that you want to have a battle. I mean in the league match. So this API will run all these functions in the background, and it will calculate the probability for both the teams, and it will tell you like what the probability of win for each of the two fantasy league teams will be. So I'm assuming this is what you mean by automation here.
Is this can be 100% accuracy, sir?
No, so this can't be predicted with 100% accuracy because again, during a real life cricket match, you can't predict anything with 100% accuracy. There can be a lot of factors that can affect a cricket match. For example, I'll give you a simple example for this one. Let's say two players are running between the wickets. One of the players slips and falls down. So there's no way to calculate a probability for this one. And since the player fell down, he got run out. And this was a completely unexpected event, which can't be factored in a statistical model or a machine learning model or an AI model. So there's no way to predict with 100% accuracy which team is going to win or what is going to be the probability of win for the team.
Okay, then. So one more question, sir, from Sasidhar. What about the outside weather conditions? They play an important role in a cricket match.
Definitely. So the weather conditions play an important role within a match. Let's take a recent cricket match that India played. So that match was, I can't remember the team against it was, but basically what was going on was that the opponent team was playing really great before the rain started falling down, and before the rain, the predictions were saying that the opponent team was going to win. But after the rain, the whole scenario completely changed. The speed of the ball by which the bowlers were bowling changed. The bounce of the ball changed. So all these factors, they completely can change the turnout of the match. So that is why outside weather, or like I said, a lot of other outside factors can change a lot of things within a cricket match. So it is not possible to predict with 100% accuracy which team is going to win or what can be the outcome of a particular match. So I hope that answers your question.
Okay. Okay, now we have come to the end. Thank you, sir. Thank you, Mr. Aman Sharma, for the wonderful session. I believe that the session of the webinar was informative for all. On behalf of IFERP, I heartily thank all the professors, academicians, and delegates who have joined us today. I would like to extend my gratitude to our esteemed speaker, Mr. Aman Sharma, for delivering his keynote address. Thank you, sir. Thank you, one and all.
Thanks a lot. Have a great day, everyone.
Thank you, sir.